So we want to use the ideas that we have put together so far with weather to help us predict weather. First of all, weather in the United States moves from west to east. So whatever conditions you see to your west, you can anticipate coming to you shortly. Weather changes will accompany the movement of high and low pressure cells across the country. With high pressure cells, you have cool, dry, nice weather. With low pressure, you have warm, moist, what you might consider bad weather, unless you like rainy days, in which case it's good weather. So, but it would be rainy days or snowy days or something like that. So let's talk about the weather in a high. Cool, dry air is more dense than usual and sinks to the ground. Remember, because it's cool, the atoms are not vibrating fast and they can get closer together. Because it's dry, it's made of the heavier molecules of regular air. Water vapor, remember, is lighter than regular air. So if it's cool and dry, it has two good reasons to be more dense than usual. So that's sinking to the ground. High pressure means that air is sinking. The high produces divergent winds. In other words, it slams into the ground and spreads out from the high. This means the winds are always moving out from the center of the high pressure cell. Highs have no fronts associated with them. The weather is usually very nice. Usually not many clouds, usually, well, it can be windy, but once you're in the middle of the high, it's usually quite calm. It's also wonderful for stargazing. The second night after a cold front has passed through, you're in a high pressure cell and the air is stabilized, and that is the best viewing conditions you will generally ever get. A low, on the other hand, warm, moist air has two reasons why it's less dense than usual, and it's rising. Remember, it's warm, so the atoms are vibrating fast. It's moist, so a lot of the heavy, dry air has been replaced with lighter water vapor. So low pressure means that air is rising. Rising air will cool, it produces clouds, and releases the heat energy from condensation. The low produces convergent winds. That means the winds are rushing into the center of the low. Now, lows. Low pressure, the rising air making clouds and releasing all that heat energy from condensation makes the low deeper, makes the air rise faster. So lows usually have two fronts associated with them. A warm front first, then a cold front. It's almost always in that order. Um, so if you're looking at a low pressure system, you can anticipate rain along the warm front and then rain along the cold front. The warm front rain is one kind of rain, long, gentle. Cold front rain is sudden, vigorous rain, and then done. So here you see the difference between highs and lows. Highs have air sinking on them and spreading out, clear blue skies generally. Lows have air rising above them, making big clouds, and the air is rushing in. When we first started really studying how weather works, it was just after World War I, and the battles between the two great armies that took place at the front. So they used the term front to talk about the weather areas between the two great air masses. So if you have a warm air mass moving in, the warm air moves over the more dense cool air. It forms a huge wedge of clouds that could be 1,000 miles across. These are characterized by stratus or layered clouds because the air is being lifted generally all at once. Whole mass of air. It's not a very steep incline, and all of the air reaches its dew point at the same time. A cold front, on the other hand, cold front is more dense, so it bulldozes its way under the warm air, forces warm air up suddenly, creating large thunderstorms. Cold fronts might be as narrow as 10 miles across. So you can see a tremendous difference between warm fronts and cold fronts. And you see down here Cold front, that's the symbology for a cold front. Warm front, if a front is stationary, you use both symbols on opposite sides, and we'll get to what an occluded front is. You'll use both symbols, but on the same side. Well, let's talk about what a warm front looks like. Here's cold air. The warm air slides up on top of it. The cold air is moved out that way. Well, this makes cirrus clouds, the very first clouds you would see. The long, thin mare's tails kinds of clouds. Then you have cirrostratus. Now, you can tell it's cirrostratus. You can see a layer of clouds. You could see the sun through it, and it hurts your eyes to look at. As the clouds get thicker and become altostratus, you can still see the sun, but now it doesn't hurt your eyes to look through the altostratus. You're just seeing a disk of the sun. Finally, the clouds get so thick, you can't see the sun through them at all. These are stratus clouds. And at the end of the stratus, you'll find precipitation. So if it's precipitating, it would be called a nimbostratus cloud. Why does that warm air slide over the cold air? Well, as always, it's a simple explanation. It is less dense. So warm front, it's characterized by that wedge and the stratus clouds. So in a cold front, well, now you have cold air moving in. The warm air is forced directly up. It makes, well, the cirrus clouds blown out in front of it. Oh, yeah. It makes cumulonimbus clouds. So cold front, it's a bulldozed mass of air coming into the warm air, and the warm air is lifted straight up. An occluded front. Well, cold fronts, which are following the warm fronts, they move faster than the warm fronts. They catch them and they lift them right off the ground. So this weather includes aspect of both fronts. And a stationary front is just a front between cold and warm air masses which are not moving. So we're waiting for motion to occur. Sooner or later, it will not stay stationary, but right now it's not moving. Let's look at that occluded front. You have the warm air mass sliding up on top of the cool air mass. But then suddenly a cold front comes in. So where you were anticipating all the warm front weather, it's ended with a cold front. Big cumulonimbus clouds. And it ends with a bang. So that's an occluded front. To make these forecasts that we so rely on, we use computer models. They look at current weather conditions and they compare them to what has happened in the past under similar conditions. If similar conditions produce snow 3 out of 5 times, the forecast will call for a 60% chance of snow. Short-term forecasts are really quite good, but long-term forecasts are unreliable. So for 3 days, forecast is pretty good. For 5, not so good. For 10 days, it's really kind of getting iffy. Mid-latitude lows are the storms that affect us the most. These are the largest storms on our planet and produce almost all of our weather, and we can understand it. So here's how. Winds shear at the polar front, producing waves. That's just winds moving in different directions. That'll produce waves. Cold air moves south, warm air moves north. This lifts warm air in both cases, causing condensation. So in this picture, you can see 3 huge fronts, 3 huge mid-latitude lows with the fronts associated with them. Look at that. Here's another one, and here's the third one. By comparison, this thing here is a hurricane. You can see mid-latitude lows are enormous compared to hurricanes. You can also see that they are in fact, the mid-latitudes. Here's the equatorial band. You can see all thunderstorms. Here's 30 degrees south, deserts, 30 degrees north, more deserts. So let's think about how a mid-latitude low works. If this line represents the polar front, that is, this would be the 60-degree line. So this is the polar front. Above here, the very cold winds are blowing this way. Below the 60-degree line, the much warmer winds are blowing this way. Well, what's going to happen in a situation like that? Well, when I have two fluids moving past each other, sort of like you see with air moving over water, you get waves. And indeed, on the polar front, what you get are these waves. So let's explore what's going to happen on one of these waves. So here we have that polar front with these waves going along it. All right, now what's going to happen in these waves? Think of it. The cold air is going to be swung south. The warm air is going to be pushed north. Well, so what? What does that matter? Well, if we remember what a cold front looks like, a cold front, okay, looks like this. It's barreling into warm air. The warm air is lifted pretty much straight up and forms a cloud. That cloud will start raining, and the cloud will release heat to the air, lots of heat. All right, well, let's look at a warm front. A warm front, the warm air slides over the cold. There's the cold air. Here's the warm air. The warm air is less dense, so it slides over the cold front this way, and it forms a whole suite of clouds, from the cirrus clouds up here to the cirrostratus here, the altostratus here, the plain old stratus, and the nimbostratus, the raining stratus clouds there. So in each case, whether it's a cold front coming down like this or a warm front coming up like this, you're going to make clouds. You're going to make clouds here. You're going to make clouds here. So this whole area, you're going to be making clouds and thus releasing heat. This is the beginning of a low pressure center here. Okay, a low pressure center, right? Makes for very low pressure. And that then, if you think about it, that's going to draw even more warm, is going to draw even more warm air in, and is going to draw even more cold air in. Well, what's that going to do? So the release of all that energy is going to make a low pressure system. And that cold air swinging south is going to make something we call a cold front. Tell these spiky things look like that. And the warm air pushing north is going to make what we call a warm front. Looks like it has pillows on it. So the warm air is moving this way, the cold air is sweeping this way, and they're making their associated cloud systems with them. So out in front of the warm front, you have a large area of clouds condensing the water. The precipitation is going to be generally quite a ways out in front of the warm front, maybe a little bit behind it. When the warm front passes, if this was your location here, it'll seem like the front is passing this way. All right, so you'll go from the cooler air, then it'll get rainy as you go into this, and as your day progresses, eventually you'll find it gets warmer and muggy. This air down here is coming up from generally the Gulf of Mexico here. So it's warm and muggy air. And if you remember the designation, it would be maritime tropical air coming up here. What would this air on here be? Continental polar air. Okay, so this is the two systems that would be interacting here. Here is your cold front, and here is your warm front. And the cold front is actually moving faster than the warm front. So it will eventually catch the warm front and zipper it up. And this would then be an occluded front and include all that weather. So this is how the weather in our world, at least in the middle latitudes, this is how almost all the weather occurs. Pretty cool. So here we have the polar front, air moving each way on the polar front. And you can see right in the middle, what we are calling this thing right here. This is a stationary front. There's no air moving. But because we have wind blowing one way on top and another way below it, that means waves are going to form along this front. So here's one of the first of those waves. And if we look at it, we have warm air surging north, we have cold air surging south. That's going to create lifting of warm, moist air and start causing condensation, maybe even a little precipitation. Where you see the green, that's where you're going to have condensation releasing enough water vapor to make precipitation. And of course, all of that is releasing vast quantities of heat, which pulls in more air. So mid-latitude lows, the condensation releases heat, causing the air to expand and rise, producing a low pressure area. The rising air pulls in more air around it, causing more condensation, releasing more heat, lowering the pressure even more. This has begun a heat engine that will continue making itself grow. So this heat engine has a warm and a cold front with a low right in between those two fronts. So as we continue pulling in more air, more cold air this way, more warm air this way, this low will deepen. You'll get more condensation because it's pulling in much more water vapor, and the low gets lower pressure because you're releasing so much heat. And the cold front moves a little faster than the warm front, so it starts eventually catching it. You see these kinks in the low? See how the low is kinked over on this side of it, and it's kinked on this side? This is a good indication where the fronts are. And because the cold front moves faster than the warm front, it starts catching it right here and starts zipping it up, called an occluded front. When it occludes it, I hope you see, that's going to kill off the entire storm. This is how a mid-latitude low dies. Otherwise, they would just keep circling the world. The mid-latitude low dies when the cold front catches the warm front, lifts it off the ground. So this is mostly all occluded. There's still a little bit of action right in this area, but the storm basically is done for at this point. The low has wrapped itself up and will blow itself out in a couple days. But because there's really no more condensation, once you've occluded, you've held all the warm air aloft. You can't condense it anymore. So only along the still alive cold front can you get much action happening at all. So the low at this point is pretty much dead. So this is another way of looking at it. This is along the polar front right there. So along the polar front, you have these waves, and the warm air starts pushing north, cold air starts pushing south, starts making all of this stuff. You can see that that condensation pulls more warm air up this way, pulls more cold air down this way, and you have a living, breathing storm system. There's the cold front pushing that way. There's the warm front pushing that way. This storm will just continue now. The storm then will disconnect from the polar front and just be pulling air around it, just like this has done down here. The low has disconnected from the polar front. Here you see a warm front in front of it. Here you see a cold front behind it, just the way we were showing. It's pulling air up from the south. That would be your Gulf of Mexico, warm, moist air. And that moisture from the Gulf of Mexico is really fueling this entire storm. Everywhere that moisture is condensing, it's releasing heat, deepening the low. This thing will just keep going on its own. And this is what powers virtually all our weather here in the United States. These giant storms known as mid latitude lows. So some natural hazards. Well, we understand that condensation releases huge quantities of heat into the air. It's comparable to nuclear bombs worth of energy. This heat disturbs the atmosphere greatly, resulting in fierce storms like thunderstorms, tornadoes, hurricanes, when they occur, of course, are releasing vast amounts of heat from all the condensation you get over the open oceans. Um, and with storms as intense as these, you really need to learn how to duck and cover. Once in a while, your life may depend on you taking weather seriously. Most of the time, the weather is just beautiful. And at its worst, it's really not too bad. But you've seen bad storms, and you know that the wind can get pretty severe sometimes. Chances are good you have never seen really bad storms or truly intense wind. So, recognizing that you have not seen nature at its worst at all, we should always be prepared for nature to become a little bit more severe, especially if you live near the ocean. So, thunderstorms we need to learn to worry about. Thunderstorms occur when very warm, moist air is pushed violently upward. Now, when does that happen? That's a cold front. That's when you throw the air up very violently. This causes condensation and a release of huge amounts of heat. So, what do you get? You get heavy precipitation, lightning, hail, and tornadoes may occur with strong thunderstorms. To worry about it, to deal with it, stay away from the wind and the lightning. These can drop trees on roads. The lightning can be extremely dangerous. Watch for flash floods. These are streams that start small and get raging very suddenly. Driving is not always a good idea in a thunderstorm. Things get out of control sometimes very quickly. Flooding is the biggest danger, but trees down, bringing power lines down on road can be life-threatening hazards. So thunderstorms can be something we need to worry about. So there you go. That is a thunderstorm seen from quite a distance away. This flat top you see right up here, that is the top of the troposphere. The thunderstorm goes up until the air above it is much less dense. That's because the stratosphere starts warming the air. So this is as high as the rising column of air can go. But this thunderstorm here from top to bottom can even easily be 7 miles high. This is huge. So the rising air begins going up, continues going up. You start having some rain start finally falling down, and that's going to hold the air and pull the air down with it. Finally, a thunderstorm has so much air going down in it that it really kills the thunderstorm. On the other hand, this air coming out often builds up little baby thunderstorms on each side that can then develop. So a thunderstorm usually only lasts for an hour, but it's giving birth to new thunderstorms that can continue the cycle. Look at that. Enormous amounts of energy being released. Thunderstorms are very dangerous, but exquisitely beautiful things to see. This is the way we usually see it, though. You can tell it's hard to see it. Right here is the actual pile of clouds going up, right? You can't see anything over here because there's so much rain. The rain pretty much obscures things all the time. But this whole thing over here is the top of the anvil cloud. So this is a huge thunderstorm. If you learn to see properly in the sky, you will see the most amazing and beautiful things. A lot of people could look at this and not see anything at all. When you look at it, if you could see the object that it actually is, you'll be impressed. So thanks for taking a look at all this stuff. Look at that. Oh, it's beautiful. So hurricanes. Well, we should talk a little bit about hurricanes and tornadoes and those terrible things. Hurricane begins as a tropical depression, low pressure in the warm waters between Africa and South America, at least for our hurricanes. The storm gathers energy from the heat released from the condensation of warm, moist air. A hurricane occurs when the winds exceed 74 miles an hour. The central eye, when you can see a central eye in the hurricane, that's calm. The storm is massive and destructive. It brings winds, high tides, and floods, generally to areas quite near the shore. And it's the floods that are by far the worst parts of the hurricane and the most destructive things. So these are things to worry about. The winds can become absolutely incredible, and what they can do is devastating. So if a hurricane is coming ashore, pay attention and do what they're telling you. Evacuate if they're telling you to evacuate. Because while a lot of times it isn't so bad, oh, by the time it starts getting bad and they realize it's getting much worse than they predicted, which happens a lot, there's no place to go. That would be a terrible hurricane. You could see the eye very clearly here. In there, it's calm. There's been many times when the hurricane has come ashore. Suddenly the winds die down. People leave their houses to go see the destruction, and they're out for a long walk. And they look up, and there's the other edge of the eye wall. They were actually in the eye of the hurricane. It wasn't done at all. And they're about to get full force, devastating winds. That's a hard thing to find, that you're out in the middle of it. This is where hurricanes for us are typically born, right? In the Atlantic right here. And this is the typical paths. You can see they intersect with the United States pretty often. Tornadoes, a tornado descends from a severe thunderstorm. You pretty much don't get a tornado unless there is a thunderstorm. Now, usually the worst ones occur during the spring and early summer in the central U.S. Warm, moist air collides with cool, dry air to produce conditions very favorable to tornadoes. So it's narrow, rarely more than half a kilometer across, but the wind speeds may exceed 500 kilometers per hour. That's like over 300 miles per hour. So that will tear a house apart. That will do severe damage. Where's a safe place in a tornado? Well, preferably in a basement. Underground is the only real safe place in a tornado. Cars are not safe. Fortunately, a tornado usually only lasts a short period of time. A hurricane, on the other hand, when the hurricane is on top of you, that's going to last for a very long time. As long as it's not on you, it's a beautiful thing to see. But wherever that tornado is, that is what terror really is. That's a tornado getting very close. And you can see one of the ways to tell if there is a tornado in your area, please look for debris in the air. If you start seeing debris in the air, you know a tornado is very, very close, and you are in a deadly threat. So learn to watch out for these things, learn to duck and cover. That's the weather for you. Thanks so much for paying attention.